Types of quadrilateral and their properties. A parallelogram is a quadrilateral in which both pairs of opposite sides are parallel. Quadrilateral ABCD above is a parallelogram. Both pairs of opposite sides are parallel. That is, line AB and line BC are parallel. Line AD and line BC are also parallel. Next, a rectangle is a parallelogram with 4 right angles. Quadrilateral EFGH is a rectangle. It is a subset of the set of parallelograms. Both pairs of opposite sides are parallel. Angle E, angle F, angle G, and angle H are right angles. This means the measure of each angle is 90 degrees. This is indicated by the symbol this at each vertex. Next, a rhombus is a parallelogram with 4 congruent sides. Quadrilateral IJKL is a rhombus. The set of rhombi, plural form of rhombus, is a subset of the set of parallelograms. Both pairs of opposite sides are parallel. The 4 sides, line IJ, line JK, line KL, and line LI are congruent. This means they have the same length. Next, a square is a rectangle with 4 congruent sides. Quadrilateral MNOP is a square. The set of squares is a subset of the set of rectangles. It has 4 right angles and at the same time 4 congruent sides. Here, as you can see, they are right angles. Next, a trapezoid is a quadrilateral with exactly 1 pair of parallel sides. The parallel sides are called the bases of the trapezoid. The non-parallel sides are the legs. The angles formed by a base and the legs are called the base angles. In a quadrilateral, QRST is a trapezoid. Angle QR and line QR and line TS are its bases, and line QT and line RS are its legs. Next, angle Q and angle R are its base angles. Angle TS, angle T, and angle S are also base angles. Next, Theorem 4-1. Theorem 4-1. A diagonal is a parallelogram forms 2 congruent triangles. Here, a diagonal of a parallelogram forms congruent triangles. Here, there are 2 congruent angles. The triangle ABC and triangle ADC are congruent. Next, corollary 4-1.1. In a parallelogram, any 2 opposite angles are congruent. Here, any 2 opposite angles are congruent. It means angle B is congruent to angle D, and also angle A is congruent to angle C. Next, Theorem 4-2. In a parallelogram, any 2 consecutive angles are supplementary. Here, in a parallelogram ABCD, angle A is supplementary to angle B. It means that their measure, if added, is equals to 180 degrees. Also, angle A is supplementary to angle B. Next, Theorem 4-3. In a parallelogram, any 2 opposite sides are congruent. Here, line AD is congruent with line BC, in which they have the same length. Theorem 4-4. The diagonals of a parallelogram bisect each other. Here, if we have two diagonals, the diagonals of a parallelogram bisect each other, it means they have a point of intersection. Next. Theorem 4-5. If two lines are parallel, then all points of each line are equidistant from the other line. Here. If two lines are parallel, like line HE and line GH are parallel, it means if there's a point here and a point here, they have, and a point here and another point here, they have the same length from each other.